Hello everyone. So in this video we'll be solving some problems from the fins. So here we are having a problem. One end of a very long aluminum rod is connected to a wall at 140 degrees Celsius, and while the other end is in an atmosphere of 15 degrees Celsius. The rod is 3 mm in diameter and H value between surroundings is given 300 watts per meter square Kelvin, and here we have to find the total heat dissipated by the rod or by the fin, and the K value for the fin material, which is aluminum, is given. So first we have to identify under which case this fin is coming. Here it is mentioned that the fin is a very long. So this is coming under the case 1. Case 1 fin we are having. So case fin, here you have to only find the total heat dissipated by the rod. So here you have to calculate the total heat dissipated by the fin or transferred by the fin, and so you have to obtain the equation. So from data book, so you are having the infinitely long fins you are having here, and the temperature distribution is given in this equation: T minus T infinity divided by Tb, or T naught minus T infinity equal to e raised to minus mx, and the heat transferred by the fin is also given, square root of Hpka into Tb minus T infinity. So you have to find only the heat transferred by the fin. So Q fin is equal to square root of Hpka into T naught minus T infinity. This is the only required equation from data book. In oral term, H is given. H is the heat transfer coefficient between fin and material, which is 300 watts per meter square Kelvin SI unit, and P is the perimeter of the fin. So first you have to obtain the or understand the shape of the fin. Here we are having a rod which is 3 mm in diameter. Rod ആണ് ഇവിടെ fin ആയിട്ടുള്ളത്, means you are having a circular or pin fin you are having. So this is the fin shape which is having some length, and this is extending from surface, or which is known as the base. So here base is coming, and base temperature will be denoting it as T naught, and the atmospheric temperature will be denoted as T infinity, where T naught is 140 degrees Celsius and it is extending an atmosphere of 15 degrees Celsius, means T infinity is 15 degrees Celsius. So you are having both T naught and T infinities are known. Next you have to find the perimeter. So here you are having a circular fin or pin fin which is having diameter, for which the perimeter will be pi times d, and you are having K value is given, which is in SI units 150 watts per meter Kelvin, and AC is the cross sectional area of the fin. Here we are having a circular fin, therefore cross section is pi by 4 into d square. So where d is diameter of the pin material, which is 3 mm, or SI units 3 into 10 raised to minus 3 meters. So yella substitute cheyuka, therefore you will be obtaining the Q fin equal to square root of 300 into pi into 0.003 into K 150 into pi by 4 into d square 0.003 square into T0 minus T infinity, which is 140 minus 15 degrees Celsius, or this is difference is in degrees Celsius, or the difference is also in Kelvin units also. So if you are solving this, you will be getting the heat transferred from the fin, which is equal to 6.843. This is actually in heat transfer, we are discussing about the rate of heat transfer only, and this will be having a units of joules per seconds or watts. So this is the required answer for this fin problem. Next we are having the other problem. In an experiment to determine the thermal conductivity K of a long solid which is 2.5 cm in diameter rod, its base is placed in a furnace with its large portion of it projecting into a room at 22 degrees Celsius. After steady state, the temperature at 2 points which are 10 cm apart are found to be 110 degrees Celsius and 85 degrees Celsius. The heat transfer coefficient H between the rod and surrounding is 28.4 watts per meter square Kelvin. Here we have to find the thermal conductivity of the fin material. So here also we are having a case of a long which is giving you the case 1 fin. So here also we are having the case 1 fins which are infinitely long or very long fins ആണ് ഉള്ളത്. So very long fins are you are having. So here next you have to identify the shape of the fin. It is said that it is a solid 2.5 centimeter diameter rod. Means here also you are having a circular or pin fin which is extending from surface, and the diameter of this pin is given as 2.5 centimeter, and it is extending from the base. Here base temperature is not given, so I will be calling it as T0, and it is in an atmosphere of T infinity equal to 22 degrees Celsius. Here we have to find the thermal conductivity of the material, means you have to find the K of the material. And here whatever the data given is temperature at 2 points 10 which are 10 centimeter apart. ആ രണ്ട് പോയിന്റ് എവിടെയാണെന്ന് പറയുന്നില്ല. Suppose first point is here and its temperature is given, which I am calling it as T1. T1 is given as 110 degrees Celsius, and there is another point which is point 2, and out of the temperature I am calling it as T2 which is 85 degrees Celsius. ഈ പോയിന്റുകൾ തമ്മിലുള്ള ഡിസ്റ്റൻസ് ഈസ് 10 സെൻറ്റിമീറ്റർ തന്നിട്ടുണ്ട്. സോ ഫസ്റ്റ് ബേസിൽ നിന്നാണ് ഐ എം മെഷറിങ് ഓൾ ഡിസ്റ്റൻസസ്, അതിനെ ഞാൻ x1 എന്നും വിളിച്ചു, ആൻഡ് ബേസിൽ നിന്നുള്ള രണ്ടാമത്തെ ഡിസ്റ്റൻസിനെ ഞാൻ x2 എന്നും വിളിച്ചു. അങ്ങനെയാണെങ്കിൽ ഈ x1 എനിക്ക് അറിയത്തില്ല, സോ ആ ഡിസ്റ്റൻസ് ഐ വിൽ ബി കോളിംഗ് ഇറ്റ് as x1 as such, and x2 distance will be, these points are 10 centimeter apart, therefore x1 plus 10 centimeter ആണ്. If I am using the SI on it, this is x1 plus 0.1 meter. Assume x1 and x2 are used in meters. ഇങ്ങനെയാണ് തന്നിരിക്കുന്ന ഡേറ്റ. സോ ഇതിൽ നിന്ന് നിങ്ങൾക്ക് തെർമൽ കണ്ടക്ടിവിറ്റിയാണ് കണ്ടുപിടിക്കുന്നത്. അതിന് ഫസ്റ്റ് യു ആർ ഹാവിങ് ദി ഇൻഫൈനൈറ്റ്ലി വെരി ലോങ് ഓർ വെരി ലോങ് ഫിൻസ്, അതിൻ്റെ ടെമ്പറേച്ചർ ഡിസ്ട്രിബ്യൂഷൻ ഡേറ്റ ബുക്കിൽ നോക്കിയെടുക്കണം. സോ ഹിയർ ഫസ്റ്റ് കേസ് ലോങ് ഓർ ഇൻഫൈനൈറ്റ്ലി ലോങ് ഓർ വെരി ലോങ് ഫിൻസ്, ടെമ്പറേച്ചർ ഡിസ്ട്രിബ്യൂഷൻ ഈസ് T minus T infinity divided by B minus T infinity equal to e raised to minus mx ആണ് ജനറൽ ഇക്വേഷൻ. സോ വി ആർ ഹാവിങ് general expression for temperature distribution is T minus T infinity divided by T0 minus T infinity equal to e raised to minus mx. അതായത് if you are having a point which is at a distance of x from the base, then the temperature is T. Here you are having 2 points which are at a distance of x1 and x2 from the base surface. So I will be applying this for both the points. If you are applying for the first point, then you are having, for the first point you are having T1 minus T infinity divided by T0 minus T infinity equal to, and for the second fin you are having T2 minus T infinity divided by T0 minus T infinity equal to e raised to minus m into x2. So you are having two relations. Here I am calling it as first equation and this as second equation. If I am taking the ratio of this 1 and 2, if I am taking ratio of 1 and 2, then I will be obtaining T1 minus T infinity divided by T2 minus T infinity equal to e raised to minus mx1 divided by e raised to minus mx2, which is equal to, if I am substituting x2 as x1 plus 0.1 meter, then you are having finally e raised to minus mx1 minus m into 0.1, which will be going to the numerator, and you are having e raised to 0.1 into m. This m എന്ന് പറയുന്നത് ഈ നമ്മുടെ ഇക്വേഷനിൽ m ആണ്, ഇതെന്ന് പറയുന്ന മീറ്റർ ആണ്, കൺഫ്യൂഷൻ ആവരുത്. ദിസ് ഈസ് ഇൻ യൂണിറ്റ്സ് ഓഫ് മീറ്റേഴ്സ്. ആക്ച്വലി യൂണിറ്റ് മീറ്റർ ആണ് ഞാൻ എഴുതിയിരിക്കുന്നത്. ദിസ് ഈസ് നമ്മുടെ എം ഇക്വേഷൻ ഡിറൈവ് ചെയ്തപ്പോഴുള്ള സബ്സ്റ്റിറ്റ്യൂഷൻ, വിച്ച് ഈസ് ആക്ച്വലി സ്ക്വയർ റൂട്ട് ഓഫ് h ഇൻറ്റു പി ഡിവൈഡഡ് ബൈ കെ ഇൻറ്റു എ സി എന്നുള്ള ടേമാണ് ഈ എം. ഇത് കൺഫ്യൂഷൻ ആവരുത്. ഇനി സബ്സ്റ്റിറ്റ്യൂഷൻ കൊടുക്കുക. T1 ഈസ് 110 degrees Celsius minus atmosphere 22 degrees Celsius divided by T2 is 85 minus 22 equal to e raised to 0.1 m. ഇത് സോൾവ് ചെയ്യുക. അതിൽ നിന്ന് m ന്റെ വാല്യൂ കണ്ടുപിടിക്കുക. So if you are solving this one, then you will be getting left hand side 110 minus 22 divided by 85 minus 22. This is so this 1.139 is actually e raised to 0.1 m. So 0.1 m will be equal to log of this answer. So m will be equal to this value divided by 0.1. So from this you will be getting m will be equal to 3.34, and this m is actually we are having this m is having the substitution or equation which is square root of hp divided by k into ac. From this h is given, p perimeter you can find for a circular cross section, area is also given, only thing is k. So you have to find the value of k. If m is 3.34, then m square will be square root of square of this answer, which is 11.169, which is equal to h value, h is equal to 28.4 SI units. I am substituting like this, and perimeter for the circular fin, perimeter is pi into diameter, diameter is 2.5 centimeter or 0.025 meter divided by k. I have to find k into cross section area pi by 4 d square for circular cross section. So it is pi by 4 into 0.025 square. If you are solving this one, then you will be obtaining the final k value, k equal to 46406.5 watts per meter Kelvin will be the answer. So this is the final answer for this problem. Thank you.